All right, students, we're going to cover homework section, Module 8, Homework 1 now in this lecture video. And so question number 1 we're going to be dealing with is solving equations that are in the expression of rational orientation. So this is in that rational expression. So we're looking at defining first values that could be produced that don't work for the equation. And we look at the expression, that's the rational expression, and define what values causes it to be undefined. So we know that we can't ever divide by 0. So when we talk about dividing, we want to go ahead and set the denominator equal to 0 to determine what that value will be equal to in order to determine what value we can't put into the denominator. Because we're going to solve equations, we need to know what we call extraneous answers. Answers that are produced, but then don't work for the original equation. So we set it equal to 0 for that reason, and then we're going to go ahead and subtract 18 from both sides, or simply put 18 the other side, and then we get negative 18, and then divide both sides by 3. And then we get x equals negative 6. So then that would produce a 0 in the denominator and equal our value because it will give us an undefined value. So that's number 1. So we notice we're not too concerned about the numerator when we're talking about undefined values. So we're going to focus on the denominator. So in number 2, it's a quadratic. So in this case, we go ahead and set it equal to 0. And then we go ahead and there's a couple of different ways we could do it, but we're going to do it by factoring. Put two numbers multiply together to create 5 that add up to 6. And that will be 5 and 1. All right, 5 and 1. And then we're going to go ahead and make it become x cannot equal then negative 5 and negative 1. All right. So that's the answer we're looking for there. So we would go ahead and put that as our answer. Now, it doesn't matter which order you put it. I mean, you could put negative 5 and then negative 1 and then what they have here. Okay, now they give you multiple choice. Okay, so we're going to go ahead and look at the denominator again, set it equal to 0. And then we have negative 12 times, or excuse me, it'd be negative 1 times positive 12 that equals negative 12 that adds up to positive 11. So we're going to get this. And then, of course, that means that we have x cannot equal negative 12 and positive 1. So we're going to go ahead and put that as our answer. All right, this is right here. So they keep on doing this, all right, until they exhausted the fact that they want to make sure you understand that you have to concentrate on the denominator. I mean, so this is just an exercise on endurance, I suppose. But now we have this situation. Now we can go ahead and multiply. All right, and then divide 216 by values that see what equals 15 when we go ahead and subtract. So dividing it, like for example, 6 times 36 is 216, but that doesn't add up to 15. So we're going to keep on going. So we have 27 times 8 is 216. When we subtract 8 from 27, that gives us 15. So we're going to go ahead and put the value of 27 and negative 8. All right. And now we're going to go ahead and take 27 over 4 and then negative 8 over 4. This one doesn't reduce down at all, so then we're going to leave that as 4x plus 27. And then we have this reduces down to negative 2 over 1, which then means we have 1 times x minus, all right. So now we have that. We're going to say that the values of x cannot equal negative 27 over 4, and then we have positive 2, right? So that's our answer. We come up with that. All right. Now 27 over, they have 9. What's that? Let me see. What happened? Perhaps I could have factored out something. Let me see. How did I get that one wrong? Let me see. Did I copy anything wrong? No. No. Okay. So what did I do that wrong? I can't see how I did that one wrong. I got that. Okay. I don't see the error. I can't see the error. Okay. Well, anyway, yeah. Okay. Thanks, Ryan. I mean, I don't see the error. I can't see it unless I type something wrong. All right, you got it. All right, you got it to be what? The negative 6. What did I do wrong? I mean, because I don't mind. Give me the answer. I'm just double checking some of my work, but 7 and then 27 over 4. 27. Oh, isn't it? It's not. That's funny. That's true. Holy shoot! Thanks, buddy. You know what? I went ahead and added that in my head. That's true. Oh crap. That's right. That's not equal. Thank you. You're a beautiful person. I love you. That is so true. In my mind, what happened? Why did I make a mistake? Because you know what? 8 plus 7 is 15, right? So I went ahead and added that instead of subtracting it. That's what I did. So thanks, Ryan. Yeah. Okay. See, so that's good. So it's going to be 4x minus 9. And you know what? And you know what I should have done to determine that? Because this is going to equal that. This is going to equal that. But when I go ahead and multiply together, this times this, and then that times that doesn't equal that. That's exactly right. Okay. That's what my problem was. I didn't double check my work. My mind went and said 8 plus 5 or 8 plus 7 is 5, and I thought it was 15 and whatever. So my mind didn't work right. So thanks, Ryan. All right. So you guys got the idea that you guys got to factor, right? Do it properly. Now that moves on to number 5. So we're looking at equations. We have to go ahead and solve them like we do any other equation, but we have to make sure we watch out for our values that create zeros in the denominator. That's what we have to watch out for. So we're going to go ahead and do this. And then go ahead and multiply both sides by x minus 4. And then we're going to go ahead and add 4 to both sides. And then 8 minus 4, all right, is in fact, all right, let me Right there. Let me move that up. 8 minus 4 is 4. 4 divided into 4 equals 1. So that works. All right. Now, we always are checking our answers. So you notice how I plugged it in. I did it manually, like I did it mentally, so I don't have to go ahead and physically do it. Now, look at this. Now, when we see this right here, okay, we can factor out a 6 and get 6x minus 6 for the denominator. Now, the reason why I care about doing that is because now what we want to try to do is eliminate all of our values with fractions. We want to try to eliminate them. So I'm going to go ahead and multiply both sides by 6 times x minus 6. When I do, I multiply this side by that, and I multiply this side by it. Now, this will take this completely out, but then we have to distribute it to this. So that would have x minus, and then it's 2 times 6 is 12 times x minus 6. And then this will wipe this out, leaving us with 6 times 1. All right. Now, that's a little trick that's pretty simple if you kind of realize all you're doing is multiplying this 6 times this negative 2, and that's why the negative 12. Now I want to go ahead and do the distributive property. And then I want to combine like terms. And then that's going to give me negative 66. And then I'm going to go ahead and do this. Negative divided by negative is positive. 66 divided by 11 is 6. Now I come back up here and I see 6 minus 6 is 0. All right. So then my answer will be no solution, or DNE does not exist. All right. So that's when we have to be careful with that. So input yes or no here. Does the equation have a solution? The answer is no. And the reason why is because when we go ahead and solve it, all right, it doesn't work. So the answer is DNE, or does not exist. Why we learned about going ahead and solving for values. Okay. Now, when we have this, we're going to go ahead and do the same exact thing. We're going to make the second fraction there. We're going to take out the 3. All right, now when we have that, we're going to multiply, just like we did in this one, we're going to multiply both sides by 3x minus or plus 1. Okay, so we're going to get this. And then this takes this out, leaving us with 3 times 6 is 18. And then we multiply this times, oh, wait a second. Now, I just noticed this had a 2. So because there's a 2 here, I'm going to have to multiply by actually 6. I want you guys to recognize something here. When I multiply by 6, it's because there's a 2 here. I got to wipe this 2 out as well. So I didn't realize this 2 is here. So I went ahead and changed the 3 to 6. So when I go ahead and multiply this out, it'll wipe out that 2. So now I have 36. And then when I multiply this times this, the 2 goes into the 6, gives me negative 3 times this 3, which then I'm going to change that to 9. Because so 2 goes into 6 3 times. 3 times 3 is 9. And then I'm going to go ahead and get this right here. All right, now I wiped out that fraction. And then this will wipe this completely out, leaving me with just 6. So really important stuff that I just did there, okay? I went ahead and found the LCD between all 3 denominators, just not 2 of them. All right, now I go ahead and right here, you need 2 on the other side. That would, yes, because see, I'm so glad I didn't change this to here to 6. I'm so glad I had somebody checking me. 3 goes into 6 2 times. So yes, I need that 2 times that 6 gives me 12. I love that guy. His name's Ryan. This guy is my checker. He is amazing because I didn't change this side. I changed this side, but I didn't change this side. So the 3 goes into 6 2 times. 2 times 6 is 12. So now I have to go ahead and subtract 36 from both sides. Okay. Now that's going to give me negative 24. All right. And then I'm going to go ahead and divide both sides by 9. And then I'm going to have a fraction of a negative divided by negative is positive, and then 24 over 9 is going to give me 8 over 3. All right. And then I'm going to go ahead and subtract 1 from both sides. Now, when I subtract the 1, I'm going to go ahead and put 3 over 3. And that ultimately leaves me with then 5 over 3. All right, Sophia. All right, now I have that, okay? And I appreciate Ryan double checking me. Because if I accidentally forgot to put that, all right, that 2 over here, because the 3 goes in the 2, that would have messed up this side, by the way. I would have gotten a jacked up number. I would have, because originally I had 6 over here, and that would have been a hot mess. So now moving on. So I appreciate my good student. All right, now I go ahead and check this. And now what I realize is that I better make sure, okay, this one looks exactly the same as the other one, is that I have this, and this one feels like exactly the same, except now, okay, so they changed up the numbers on the top. So this one's going to feel a lot like the other one. So let's go ahead and do this one. So I'm going to factor out the 3. My LCD this time, not making the mistake again, because I actually had a transcription error over here because I didn't include that 2. Now I have that. Okay. Now distributing this knocks this out, leaving me with 6 times 9 is 54. 2 goes into 6 3 times, leaving me with then 3 times negative 1 is negative 3x plus 1. And now again, this will knock this out, leaving with 3 goes into 6 2 times. 2 times 8 is 16. Now I go ahead and subtract 54 from both sides. All right. Now when we subtract that, okay, 16 subtracted basically from 54. You get negative 38. You divide both sides by negative 3. Now, 3 doesn't go into 38. It goes into 39, but not 38. So we're just going to leave it like this and then just put positive 38 over 3 and then bring the 1 over. It becomes 3 over 3. All right. And then we're going to go ahead and put down x equals, and then it's 35 over 3. All right, now we're on a roll. Now we continue. Now with this right here, there's a lot of times when they're going to give you equations where you have the factor form of an equation that's already that's going to give you the same value. So what do I mean by that? So let's take a look at the factor form of that quadratic there. Now the quadratic, if you think about it, it's going to be equal to exactly, if we go ahead and look at this carefully, seeing these to equal x squared plus 2x minus 3, we can just go ahead and put this in the factor form of that. And that happens a lot with these because they know that they're going to go ahead and ask you to multiply both sides by the factor, or the LCD. So we multiply this side by that. All right, now that we've done that, excuse me. We're going to go ahead and basically wipe out these things. So this is going to wipe this out, leaving me with this x plus 3 times x plus 1. And then it's going to be this wiping this out, leaving me with negative 3 times x minus 1. And then I'm going to go ahead, and this is going to completely wipe all that out, okay? And then I'm going to go ahead and be left with just positive 8. All right, I'll let you look at that for a little bit. And then now that I have no fractions anymore, I'm going to go ahead and know that this right here then equals this. And then I'm going to go ahead and bring everything over to this right side, or left side, excuse me. This comes over and makes it become positive 7x. Then this right here wipes this out because 3's on both sides, right? So that means I have negative 8. And then in factor form, this is going to equal x plus 8, x minus 1. So my answers are x equals negative 8 and positive 1. Now I want to come back into the original equation and recognize that 1 minus 1 would give me a 0, so that throws this one out. And then 8, negative 8, it will work out 99.9%. I'm not even going to go ahead and check it because we just see that we want to wipe out one of our easy throwaways, and that's this one. So my answer is negative 8. Now that one is like basically as hard as it can get. I mean, these kinds of questions. Now we have t. We're going to multiply both sides by t to wipe out the t. So that leaves us with t squared minus 12. I'm going to bring the one t that's negative over, make it become positive t, and then minus 12 equals 0. And then it's going to be 3 and 4. So t plus 4, t minus 3. So t equals negative 4 or positive 3. Now, that doesn't make a 0 appear in the denominator, so we're good to go. Now, let's take a look at this one. Always factor out the denominator, so that's going to be in factor form, x plus 3s minus 3. And again, just like this one over here, okay, where we saw that this was the two factors of this, this happens to be the same exact idea, that this is the two factors of this, right? These are the same. So I'm going to go ahead and multiply both sides by, and the way we could do it, we can go ahead and multiply both sides. Well, no, let's do it in factor form. I was going to put it in its difference of two squares form, but that's not appropriate for this. So I'm multiplying this side and this side by the same thing. So when I go ahead and do this, this will wipe this out, leaving with the 5 plus, and then I'm going to go ahead and distribute this. This is going to wipe this out, leaving with the positive 6 times the s plus 3, or excuse me, minus 3. All right, and then I'm going to wipe this out with this, leaving with 1 times s plus 3. Now that I have that, I'm going to go ahead and clean this up by bringing everything to the, well, there's no squared, so I'll just do the distributive property first. So 5, and then 6s minus 18 equals s plus 3. Do the distributive property first. I'm going to go ahead and subtract an s from both sides. This is going to become negative 13, so I'm going to go ahead and recognize that's negative 13. And then I'm going to add 13 to both sides. So then this is going to be subtracted. So that's going to be 5s. This is negative 13. That's going to become positive 16 because I'm going to add 13 to both sides. Then I'm going to divide both sides by 5. That's not going to cause me a denominator that's 0. So I'm going to double check my work. Oh, there's an S here. All right, that's going to cause me to have to do some changes. All right, so I had an S. I forgot that, so I'm just bringing it in. So this is going to be 11S, and then 11S minus 1S is 10 S's. All right, that's a big deal. All right, and then this is going to change a little bit. All right, let me do this again. So this is going to be negative 18. Bring that over to there. It's going to become positive 21. And then I'm going to divide both sides by 10. And then that's going to give me my right answer. So I had to do a little bit of corrections. All right, so I had that 5S that and it's a good thing that you guys are seeing. Again, I make mistakes a lot. So that's 21 over 10. I've corrected myself. All right. Now, let's go ahead and look at number 12. It's very hard when I'm not able to look over my work. All right, so and what I mean by that is I've got my foot hanging up in the air here. Hi, here's my foot. All right, I'm sorry. I forgot this is being recorded. All right, here we have this. We know that this is the factored form. These are the factored forms of this. So that's kind of a nice little caveat to doing this. But of course, it makes it factoring a little easier. Because you can see that factoring can become a pain in the neck. All right. Now, we're going to go ahead and multiply both sides by that. And this will wipe this out. That's kind of a nice thing. This will take this one out, leaving with x times x plus 9, then negative 9 times x plus 8, and then negative 17x minus 44. Now we're going to have x squared plus 9x minus 9x minus 72 equals negative 17x minus 44. These two wipe each other out, okay? And then I'm going to go ahead and bring over this the negative 44 to the negative 72. All right, so I have x squared, and then this comes over as positive, and then I have a positive 72 equals 0. And then 9 times 8 is 72. That add up to 17. So my answers are x equals negative 9 and negative 8. Now we go ahead and put that back into the equation, and it looks like we have a problem. All right. I'm making sure. Yeah. Okay. So I like to double check, but yeah, that does seem to work. So the answer is D and E, as both these answers don't work. All right. We're going to go ahead and, you know what? I'm going to show you, I'm kind of getting a little bit tired of writing everything. Now I'm going to give you a shortcut. If the x minus 1, x plus 3 are the factors of x squared plus 2x minus 3, what I can do is cross multiply x plus 3 times x plus 1. So I'm going to write it right away. Watch this. I'm just going to write down this, and then it's going to be negative 5 times x minus 1, and then it's just going to be plus 8. I'm not going to write it all down like I did up here. Now I'm going to just do the distributive property, combine like terms, and be calling it a day. So this is going to be this is going to be positive 5 added to 8 is going to be 13. Now let's go ahead and bring everything over to the left side. And then factor this out. This is going to be x plus 10, x minus 1. So my two answers are x equals negative 10 and positive 1. Come back into the original equation, I can see that I can't have a positive 1 because I have x minus 1 in the denominator. So that throws this one out, leaving me with my answer of this one. All right. See, so this becomes very systematic. Once you've done a lot of these, you can start using tricks. I know that x plus 6, x plus 2 is the factored form of x squared plus 8x plus 12. So I'm going to go ahead and write this down as x times x plus 2. And then it's negative 5 times x plus 6. And then it's going to be 8x minus 48. So I'm done with that. Now I'm going to go ahead and do the distributive property. This is going to give me negative 3x. I'm going to bring over the 8x as negative 8x, so that's going to be negative 11x's. Then I'm going to that was hilarious. All right, and then this brings over to here, okay, and then I'm going to get positive 18. All right, now that I have that, all right, 9 times 2 is 18. That adds up to a negative 11. And then I'm going to go ahead and say x equals 9 and x equals positive 2. Now I come back to the original equation to determine if I have any zeros that fall out. And then I'm going to go ahead and see that it does not. I love you guys. You're so funny. All right. Again, now, for those of you who probably can't see what my students are joking around, I had one student who said that I could do shortcuts if I borrow your brain. So it's funny, and I love that because, yeah, it does take a little bit of training. But what that does promote is the simple idea of practice makes habit. And once you do enough of this and you're like, oh my gosh, I'm exhausted doing this, it's so much writing. You start to try to create a little bit of a shortcut. And the shortcut isn't that really short. It's a really a fundamental of understanding the essence of how it's very mimicky. And what I mean by that is like this is what I said to you. This is x plus 8, x plus 9 is the same thing as this. And then I have to go ahead and write down this is going to multiply both sides. It kind of creates this habitual system of approach where this will wipe this out, and then so it becomes this times this, and this times this, and this wipes out. That's how it really ultimately works. And it's way we do this one is the same idea. And I'm going to write this one down. I need to sharpen my pencil real quick because my pencil is completely dead now. I'm writing so much work. But you're going to go ahead and we're going to go ahead and look at it as these two are denominators, right? Oh, I just broke my pencil head again. Darn it. I'm going to love this. I'm going to have to sharpen my pencil again. Now, when I see this, I want you to see my trick a little bit better, because I'm giving it verbally to you, but you're not picking it up perhaps, maybe. But we know that 8 times 4 is 32. When we add those two negatives together, it gives us this. So that means we are ultimately multiplying by y minus 8 minus y minus 4. So when that happens, then we're going to go ahead and cross multiply these two together and then wipe this out. That's what we're going to do. So my trick is simply just that. Cross multiply, and then we have plus 3 times y minus 8, and then just write down the numerator. That is the trick. That's how that trick works. Oh my goodness, my sharpener is pathetic. Okay, so that leaves us with then doing the distributive property. So I have this. See, my sharpener is giving me, look at the bad, look how bad my sharpener is. It's leaving one half of my pencil bad. It's driving me nuts, students. Okay, now I have negative. I have then 3y. That, okay, so I have this. And you know what? Whenever I see 3y and 3y on opposite sides of an equal sign, you know what I do? I cross them out. And then I have negative 8, and then I have a negative 24. Okay, that gives me negative 32. So I have 2y minus 32 equals 6. I'm going to go ahead and bring this over. Okay. And then that leaves me with 32 added to 6 is going to give me 38. And then I'm going to divide both sides by 2. Nope, that's 19. All right, and then I'm looking at it, and it looks like there is no worries of denominator. Okay, so now I have 19 as my answer. That's the answer that we're looking for. All right. Now let's take a look at this one. Now I go ahead and look at the bottom, and I see that we're looking at a number that all of these can go into, and 40 is the answer. So 40, every one of these can go into 40. And then we need a y. So it's going to be the LCD is 40y. So now 2 goes into 40 20 times. And then that's the y's will cancel. And then I have 20 times 9. I can write. I got to make sure I remember that. So I'm going to put 180. Then 8 goes into 45 times. 5 times 3 is 15. Y. And then 10 goes into 40 4 times. The y's cancel. Leave me with 4 times 7. And then I go ahead and take 28 minus the 180. And then I go ahead and divide both sides by 15. And it doesn't go into it, so I can leave it alone. But and it can't be reduced. So that, and then I check my answer and make sure that it doesn't cause it 0, but it doesn't. So that's my answer that I've come up with. Some of these are not the friendliest numbers, of course. Now, now with these kinds of problems right here, I want to show you something with this. These are what we call proportions, and it says solve the proportion. So with proportions, we have the ability to just cross multiply. So we cross multiply each, and then we set cross products equal to each other. So we're going to get x times, x plus 2. I'll just write it down. X plus 2 times x minus 2 equals 21 times 1 is 21. This is a difference of 2 squares. So all we're going to be left with is this. And then we're going to go ahead and add 4 to both sides. And then take the square root of both sides. We're going to get plus or minus 5. So we can see that doesn't equal a 0 in the denominator, so we're going to leave it alone, and we're going to go ahead and write our answer. So proportions are really nice when they give us proportions, but they don't give us proportions all the time. So that's we just have to utilize what they give us, right? All right. Now we're going to go ahead and do that cross multiplying stuff that we talked about earlier, but this time we can notice that the other side has a 7. So we're going to go ahead and just do -9 times y minus 8, and then -16 times y minus 7 equals, and then we're going to have 7 times y minus 8, y minus 7. All right. Now I'm going to go ahead and do the distributive property. And then I'm going to go ahead and do this. I'll do that without multiplying the 7 out. What one minute? Oh. Okay, now I'm going to go ahead and do this. I got to clean up all this, right? So I'm going to go ahead and do this together. All right, so that's going to give me 25, negative 25 y's. Then I'm going to add these two together. And then I'm going to do distributive property on the 7 to everything. So 7y squared. And then I could go ahead and multiply 7 times 15. And then 56 times 7. All right. Now I'm going to go ahead and bring everything. Since this is the leading coefficient and it's positive, I'm going to go ahead and bring everything to the right. So I'm going to get 7y squared. And then I'm going to bring this over, make it where I add it together. So that's going to give me negative 80 y. Then I'm going to go ahead and subtract 184 from both sides. Actually, I'm going to go ahead and do that. 576. All right, so that's how that works so far. I mean, now this is a very, very big number system, okay? And from this point forward, you go ahead and have to factor this, and then go ahead and figure out what the two values are. All right. Now, I don't agree that they should have such a number system that's such an incredibly large value system that I'm not going to even proceed to go forward with this, but show answer, because the fact is that there's no such need for such large numbers that I'm not going to proceed to go through with finding out the factors, factoring this. I'm just not going to do it. So you guys will have to understand that this is just a matter of factoring. Now, once you get to that point, all right, you're done with the assignment, and I'm going to leave it at that. So I'm going to go ahead and that is negative. Yes. Thank you. I put accidentally that positive. Okay. Yeah, that's negative. Okay. Thank you, Amy. Okay. So you go ahead and you can factor this further from that point, and you get this 4 and then 52 over 7, by the way. Okay. I got you to this point. Because you're bringing everything over to the right side, not to the left. All right. That's why we go ahead and subtract this from, or add this to both sides. So we're good. I mean, that's why negative. Thank you.